Hi everyone, let's talk now about the relation between electric potential and electric field. Electric potential and electric field. So, the electric field, it's the minus of the derivative of the electric potential. If we have the electric field along the x-axis, it will be dV by dx. If we have an electric field along the y-axis, so it will be minus dV by dy, and so on. Now, this means that delta V, the voltage, V final minus V initial, it's minus the integral from initial to final. Let's say A is the initial point, B is the final point, of E dot, if it is EX, so it's EX dx. If we have EY, it's EY dy. If I have both EX and EY, so it's simply going to be EX dx and EY dy. So we can write it like that. Delta V, it's minus the integral of EX dx. Let me fix it here. So delta V, it's minus integral of EX dx and integral of EY dy from initial to final, from initial to final. All right, let's take an example. Let's say I have a potential in SI units that's equal to 3x squared y minus 2xy. So we need to find the electric field. Find E at point, for example, 0, 1. So since the voltage is a function of both x and y, this means I have EX and I will have EY. So EX, that's the solution now. EX, it's minus derivative of voltage with respect to x. So what's the derivative of this one with respect to x? It's going to be 6xy. And what's the derivative of this one with respect to x? It will be minus 2y. I already have a minus outside, so put this minus outside. And we substitute now. We put for x 0 and for y 1, so you will get 0 here, and here you will get minus 2 times 1, which is minus 2, so the answer will be 2. EY, it is minus dV by dy, so derive with respect to, or differentiate with respect to y. So the first one, the derivative with respect to y will be minus, I have 3x squared. And what's the derivative of this one with respect to y? It will be minus 2x. So you put for x 0, because x is 0, you will get 0 and 0, so the answer will be 0. The answer will be 0. Then, the total electric field, since I have EX and EY, it's the square root of EX squared plus EY squared. Okay. We don't have EY, it's 0, so we have only EX. We have only EX squared because EY is 0. So the answer will be EX, which is in that case 2. So E is equal to. More than that, its direction is along the x-axis because it's equal to EX and it's positive, so it's 2 along the x-axis to the right, along the x-axis to the right. If everything was in SI unit, so for sure the unit will be here 2 volts per meter along the x-axis to the right. Again, if every quantity given was in SI unit. like the voltage is an SI unit, and the values here are in meters at 0.0 meter and 1 meter. So this is how we find the electric field from the voltage. Now, let's find the voltage from the electric field. So, example 2. Example 2. Let's say I am given an electric field, E, that has two components. The x component of the electric field, it's equal, let's say, to -2. That's the x component. It's could be a function of y or x or both. And let's say EY, it's equal to y squared, for instance. So I have two components for the electric field. Electric field along the x-axis and electric field along the y-axis. I need to find the voltage between, or potential between the 2 points, along the x-axis and y-axis, and those 2 points are 1, 3 and 2, 5, let's say. 1, 3 and 2, 5. So, delta V, it's minus the integral of Ex dx. What is Ex dx? Minus 2xy dx. And x is from where till where? From 1 till 2. So x is from 1 to 2. Plus the integral of Ey dy, which is y squared dy. And this y, it's from 3 to 5. 3 to 5. So delta V becomes minus the integral of 2xy dx is going to be minus 2x squared over 2. So it's minus x squared y for sure. I have the y here. So minus y x squared. And this x is from 1 to 2. And here you will have y squared dy, so it's y cubed over 3, and the y goes from 3 to 5. So delta V becomes, we have the minus outside, minus y is considered to be constant here. Now we put for x its value. 2 squared becomes 4, minus 1 power 2 is 1. And here you have 5 cubed over 3 minus 3 cubed over 3. So delta V is going to be minus, you have minus 3y, and here you will have 5 cubed, which is 25 by 5, 125. So 125 minus 27 over 3. So 125 minus 27 divided by 3, you will get around 32.7. So around 32.7. So that will be delta V. 3y minus 32.7. So you can see that delta V depends on y in that case. We can take now an easy example for the electric potential. Let's say I have only Ex, I don't have Ey. So if you have only Ex, then simply delta V is going to be minus the integral from a to b of Ex dx. If I don't have Ey, I just have Ex. And let's do an example on that case, which is an easy case. So again, example 3. Given electric field along the x-axis is equal to, let's say, 2 newtons per coulomb. 2 newtons per coulomb. Find delta V between the point x equal 3 and x equal, let's say, 4. 3 meters and 4 meters. We need to find the potential between 3 and 4. So directly we write the formula. Delta V, it's minus the integral of Ex dx. So minus the integral of 2 dx. X goes from 3 to 4. Then this one becomes minus 2x between 3 and 4. So it becomes minus, if we put instead of x4, 4 times 2, 8, minus instead of x3, 3 times 2, 6. So the answer will be minus 2 volts. So that's delta V, which is minus 2 volts in that case. Thank you for watching.